Hi everyone, so this is a two-part video. In the first part we're going to just talk about setting up proportions, and in the second part we'll talk about solving proportions. So we'll stop the video and make two separate ones, but you're going to be using the same set of notes for stop 4, pit stop A, and then you'll use the same notes for stop 4, pit stop B. Okay, so in this first part, setting up proportions, go ahead and open that up. First thing we need to know is what's a proportion. So we've been talking about ratios and rates, and a proportion is an equation showing that two ratios are equal. All right, so it's when we take our two ratios and we say that they're equal to each other that we've formed a proportion. And we're going to talk a lot about equations this year, so this is kind of our first time to use this word, but anytime we are using an equation, we're going to be looking for that equal sign in an equation. So an equal sign is what makes it an equation. And the proportion part of it means we're going to be using two ratios. So remember, we've looked at ratios as being written in three different ways, using the word two, with a colon, and as a fraction. But as a proportion, you're going to most often see it written as fractions, two fractions. I'll show it to you other ways, but most often, and for our purposes, really, we're going to use the fractions. So here's some examples. You have 10 over 25 equal to 40 over 100. So ratio is just comparing two numbers. So I have 10 over 25, that's two numbers. And then I have another set of numbers, 40 over 100. They're equal, so this forms a proportion. So here's what I was talking about. You could use the colon, same set of numbers, 10 colon 25, 40 colon 100. This is the same exact proportion, it's just written with the colon. And then I can also use the word 2 again, 10 to 25 or 40 to 100. But you're going to see we're going to pretty much only use the fraction part because it's just easier to work with. All right, so what we're concentrating on in this video is how to set up a proportion. So you're going to be seeing some word problems, and we're going to be solving these eventually. But right now, the important part is how to set it up. If you can get that part right, the solving part is very, pretty straightforward. All right, so what I want you to think about when you set up a proportion is that you are making two equal fractions. All right, so because ratios can be written as fractions, we're going to think that these are equal to each other. And you want to start with your words first. Set up a word ratio first. This is probably the most important part of setting up your proportion, is making sure you get your words with the right numbers. And so we're going to start by doing a comparison of the words, and then we'll fill in the numbers. And then after you have your word ratios set up, you're going to fill in your 4 boxes. So we're going to make 4 boxes. And I'll show you what I mean by that in a minute. But look, if you look back here, at these numbers right here, there are 1, 2, 3, 4 numbers in a proportion. So when we write a proportion, we're going to have 4 spaces we need to fill in. All right, so let's see how that works. A worker can complete the assembly of 15 tape players, sorry, you can't see that, in 6 hours. At this rate, how many tape players can the worker complete in a 40-hour work week? So first, I want to start with the words. And to figure out what words I'm talking about in a proportion type problem, I'm looking for what's being compared. And so usually those are the words getting repeated. So in this first sentence right here, it says a worker can complete the assembly of what? 15 tape players. 15 tape players, okay, in 6 hours. So I'm going to highlight it so maybe it'll stand out to you in 6 hours. Okay, and I want to know how many tape players can the worker complete in 40 hours? All right, so my word ratio is going to contain the words tape players and hours, because that's what's being compared. I'm going to write tape players over hours. Now, could I put hours over tape players? Yes, as long as you fill in your boxes with the words, with the numbers that go with each of your words. All right, so the second step after I figure out what words are being compared is to draw my 4 boxes. So I'm literally going to draw 4 boxes. And that's going to remind me that I have 4 spots to fill in my proportion. All right, so the first number was 15 tape players. So this is why your word ratio is important. The tape players is in your numerator, so I'm gonna write 15 in my numerator, and then in 6 hours. So the 6 hours is in my denominator. Now I want to keep these two numbers together because they're a ratio, 15 and 6 hours, so 15 over 6. So I have my first two boxes filled in. And then I need to go back and set up the second ratio. So I said, how many tape players can the worker complete in 40 hours? So hours again is where? Is it the top one or the bottom one? It's the bottom one. So 40 is going to go on bottom with hours. Did they give me another number to fill in here? No, they didn't. All right, they don't tell me how many tape players, and that is what I'm going to be solving for. So what we're going to learn in the next video is how you would do that. But for now, we're just going to mark an X in that empty box. And X is a variable, which means it stands for some unknown number. And that unknown number is what we're going to be looking for in the next video. All right, so let's try another one. Carol spends 17 hours in a 2-week period practicing her culinary skills. How many hours does she practice in 5 weeks? So the first thing I want to set up is my word ratio, which means I need to go back and figure out what words are being compared. Well, 17 hours, okay, is here. In a 2-week period, practicing her culinary skills, and then how many hours, I see that being repeated again here, does she practice in 5 weeks? So I know one of my words is going to be hours. What's my second word? Well, usually the ratio is written pretty close together. So 17 hours to what? In a 2-week period. So 2 weeks. And then how many hours does she practice in 5 weeks? So that's weeks. Repeat it right there. So I'm going to use hours and weeks as my word ratio. And I do want you to write this down. And then you're going to draw your 4 boxes. That's step 2. So after you have your boxes, you need to fill them in. So this starts with 17 hours. So that would go on top because that's where my hours are in a 2-week period. So the 2 is going to stick with the 17, but it's going to go on bottom because it's a week, 2 week. And then I'm going to continue reading. How many hours does she practice in 5 weeks? So the 5 goes with what word? Week. And where's week? On bottom. So what I don't know is how many hours are in 5 weeks. So that is where I'm going to put, and you don't have to use an X. I'm just using an X because that's the most common letter to use. But you could use anything, A, pick your favorite letter, to fill in that last one. And that is what, again, we're going to be solving for later. All right, and number 3, a rainstorm produced a rainfall of 2 inches per hour. So how many hours would it take to get a rainfall amount of 1 foot? All right, so in this one, I've got 2 inches. Sorry, I'll hear my dog walking around. 2 inches, and it's per hour. Okay, remember per hour means how many hours? 1 hour. All right, so that number's there even though we don't see it. How many hours, all right, so there's hours again, would it take to get a rainfall amount of 1 foot? 1 foot. All right, so when I start to set up my ratio, I have a problem because I have inches, hours, and feet. So this is wrong. This is a problem because I can only compare 2 words. So 2 inches and an hour, or do I want to use inches and feet? Well, what would make this simpler is if I just change 1 foot to inches. So if you don't know how many inches are in a foot, you could look it up. Your star chart is available to you. But hopefully most of you know that 1 foot is equal to 12 inches. So what I'm going to do is change my 1 foot into 12 inches. Hopefully I can still highlight that. That's yeah. And then that way I'm comparing the same word. All right, so I'm going to use inches and hours, and I'm going to abbreviate. And then I'm going to set up my 4 boxes and fill them in. So I have 2 inches. That goes on top because inches is on top. Per hour, remember that's 1, so I'm going to write a 1 there. How many hours does it take to get a rainfall of 1 foot? So 12 inches would be on top here because it's inches. And then what I don't know this time, my variable is on bottom, X. Oh, my dog again, sorry. All right, number 4. The Millers drove 105 miles on 4 gallons of gas. At this rate, how many miles can they expect to drive on 6 gallons of gas? So I see miles, 105 miles. How many miles can they expect to drive on 6 gallons? And I also am seeing gallons, 4 gallons, and 6 gallons. All right, so I'm going to do miles and gallons as my word ratio. What's the next step? Draw your boxes. All right, so 105 miles, where's the 105 going to go? Up here. 4 gallons, where's the gallons going to go? On bottom here. How many miles on 6 gallons? So the 6 is going to go top or bottom? Hopefully you're saying bottom, it's gallons. And then what I don't know is miles, so it goes here. Now, sometimes people think, well, what if I read it and I put gallons on top and miles on bottom? That would be fine, as long as your numbers stick with the right word. So if I put gallons on top and miles on bottom, then I need to switch it so that the 4 is on top and the 6 is on top, because then the gallons would both be on top. All right, the last one, on her last benchmark test, Norma's ratio of correct to incorrect answers was 3 to 1. That's a ratio written with a colon, but that's how you say it, 3 to 1. If there were 36 questions on the test, how many did she get right? All right, so I've got a ratio of correct to incorrect. If there were 36 questions on the test, how many did she get right? So if we're talking about how many she got right, are we talking about correct or incorrect? We're talking about correct. So even though they switched words, they mean the same thing, correct. Now, I also need to look at incorrect. Is 36 the same thing as the number of questions she got incorrect? Because they're using 2 different words here. Correct and right mean the same thing, but incorrect answers, and there were 36 questions on the test, that's 2 different things. So incorrect is what she got wrong, but 36 questions is how many questions were on the test. That's a total. All right, so they've switched words. This is a little tricky. So I'm going to go with the questions, number this right here, as my other word. So I'm going to do correct. And instead of questions, I'm going to write total questions. Because she didn't get 36 questions wrong, that's how many were on her test. So now I'm going to set up my boxes. All right, and again, this one's a little more complicated, but we can figure it out. So the number of correct answers she got was 3 to 1. So she got 3 correct out of how many? Well, not 1. Incorrect was how many she got wrong. So if she got 3 wrong and she got 1 right, how many did she do altogether? If you add 3 plus 1, you get 4. So the total questions she for this ratio is 3 out of 4. All right, so again, what did I do? 3 to so correct to incorrect means she got 3 correct and 1 incorrect. So 3 correct, that one's easy. But you're not going to say she did 1 question and got 3 right. That doesn't make any sense. 3 questions right, 1 question wrong, that's a total. What did I do? I added that together to get the total, 3 plus 1. Okay? All right, and then if there are 36 questions on the test, all right, then that would be what? The number she got right or the total questions? So 36 would be the total, and then I'm trying to figure out how many she got right or correct. So that would be where I put my variable x. Okay, so again, we're setting up proportions. The first step when you're setting up a proportion is to start with your word ratio. So get those words written down first, and then draw your 4 boxes and fill them in. This is the second part of solving proportions. So in the first video in pit stop A, we were setting up the proportion, and now in pit stop B, we're solving the proportion. So we're using the same set of notes, but we're just completing it now. If I open this up, you can see we've already set up the proportions in an earlier part. If you didn't do this video first, you need to go back and watch it so that you already have your proportions set up, because we're not going to take the time to do that again in this part. So now that we have our proportions set up, how do we solve? How do we figure out what this x is going to be? To solve a proportion, we need to remember something. In a proportion, if the ratios are equivalent, by saying that they're equal, you're saying that they're equivalent, then the cross products are equal. All right, and by cross products, product means a multiplication. So what I'm going to do is I'm going to be multiplying across, and I'm saying that those are equal if it's a proportion. So in order to solve a proportion, you have basically 4 steps. The first thing you do is set up your word ratio. That we did in an earlier video, and that's when we compared the words. Then you draw your 4, what did we draw? 4 boxes. After you draw your 4 boxes, you fill them in. Again, this is the part we've already done. We did the word ratio, the 4 boxes, and we filled them in. All right, after you do that, you're going to be solving the proportion. The first thing you do is circle the diagonal numbers. So by diagonal, okay, I'm going to be talking about the numbers that are diagonally across from each other. Across, that's where the cross part comes, and cross products. So I'm going to circle those. And we call that a baseball bat because it's kind of the long part of the problem. And then you're going to, after you circle in, those are the numbers you're going to multiply. We call it cross multiply. And then the last step for solving is after you cross multiply, you divide. And you're going to divide by the number that you didn't circle. So remember, in the proportion, there were 3 numbers total. Okay, the 4th one is the one we're looking for. So you're going to be multiplying 2 of them and then dividing by the 3rd one. So we call that one the baseball. Some people, that helps them remember. If it doesn't help you, don't worry about it. All right, so if I go back in this first example, since I've completed the first 2 steps, I'm going to go on to step 3, which is to circle the diagonal numbers. So the 2 numbers that are diagonal from each other are the 15 and the 40. These are diagonal as well, but they're not 2 numbers. So this is my baseball bat. These are the ones I multiply. So I'm going to do 15 times 40. 0 times 5 is 0. 0 times 1 is 0. I start with the 0. 5 times 4 is 20. Carry your 2. 4 times 1 is 4 plus 2 is 6. When I add these up, I get 600. All right. After I multiply, step 4 is to divide by the number not circled. All right. So what number did I not circle? That's the 6. That's what I'm going to divide by. So over here, 600 goes inside. I'm dividing by the 6. 6 will go into 6 once. And then I have these zeros, so I still have to divide. 6 will go into 0 0 times. And then if I bring down the next 0, 6 will go into 0 0 times again. So 600 divided by 6 is 100. So what have I said? I've said that x, this missing number here, is equal to 100. And they were 100 what? Well, if I go back and look at my words, all right, I can see that the x went with tape players. So I'm answering the question. How many tape players can they make in a 40-hour work week? Okay, and so I just said that that was, 100 tape players. All right, sorry, I drew my box too small. All right, number 2. First step after you set it up is to go ahead and multiply with the numbers that are diagonal from one another. So which numbers are diagonal? The 17 and the 5. So that's my baseball bat. Circle those. Those are what I multiply. 5 times 7 is 35. Carry your 3. 5 times 1 is 5 plus 3 is 8. After I multiply, I divide by the number I didn't circle. That would be the 2. 2 will go into 8 4 times. Subtract 8. Bring down the 5. 2 will go into 5 2 times. That's 4. When I subtract 4, I get 1. Since I have a remainder, I have to keep going. Remember, we don't do remainders in 6th grade anymore. So I add a decimal, bring it up, and then I can add a 0 and bring it down. So now I'm dividing 2 into 10. I'll go 5 times. 5 times 2 is 10, and then I'm done. All right, so my answer here, I got 42.5, and that is what I'm going to say is equal to x. So x equals 42.5. And then I could answer the question, 42.5 what? Well, the question was how many hours does she practice in 5 weeks? So, and I can see X is here with hours. So this is 42.5 hours. And it's important to identify what you're solving for because you're talking about two different types of things. So we want to make sure we've answered the question. All right, and number 3, I'm looking for the diagonal numbers. So this time, that would be the 12 and the 1. 1 times 12, 12 times 1 is 12. After you multiply, you do what? You divide by what you haven't used. That third number here, that's our baseball. So we're going to divide 2 into 12. That'll go 6 times. So now I can say X is equal to 6. X or whatever letter you used. 6 what? What's down here? So it must be 6 hours. Okay, and the question I'm answering, how many hours would it take to get a foot of rainfall? 6 hours. Number 4, the Millers drove 105 miles on 4 gallons of gas at this rate. How many miles can they expect to drive on 4 gallons of gas? Or sorry, 6 gallons of gas. So I'm going to look, since it's set up for my diagonal numbers, that's the 105 and the 6. And that's what I'm going to multiply, 105 times 6. 6 times 5 is 30, carry your 3. 6 times 0 is 0 plus 3 is 3. 6 times 1 is 6. All right, am I done? Nope. I still have to divide by this last number, this 4. I'm dividing 4 into 630. 4 will go into 6 once. When I subtract, I get 2. Bring down the 3. 4 going to 23 5 times. 5 times 4 is 20. Subtract, I get 3. Bring down the 0. 4 going to 30. 7. 7 times 4 is 28. When I subtract 28, I get 2. All right, I have a remainder. I don't do remainders. Add a decimal, bring it up. Add a 0, bring it down. Sorry, there's not a lot of room. 4 will go into 20 5 times, and then I'm done. All right, so my answer here is 157.5. Again, I want to know what that is. 157.5 what? Well, if I look at my word ratio, I can see that it's miles. So this is how far they're going to drive on their 6 gallons. And then in the last one, number 5, I'm going to, is this still recording? Yeah, it is. Okay, sorry guys. My phone was telling me it's in low power mode. Okay, on her last benchmark test, Norma's ratio of correct to incorrect was 3 to 1. If there were 36 questions on the test, how many did she get right? Okay, so I've already set it up. So my step now is to multiply diagonally. So that would be these two numbers here that are across. 36 times 3. I can write these also in any order. So I like to have my bigger number on top when I multiply. 3 times 6 is 18, carry your 1. 3 times 3 is 9, plus 1 is 10. And then I still need to divide by that last number, 4. I'm going to divide 4 into 108. 4 are going to 10 twice. That's 8. When I subtract, I get 2. Bring down the 8. 4 are going to 28 7 times. And then I can stop because I have no remainder. All right, so what did I find? X is equal to 27. And that's 27 what? Correct answers. All right, so again, as a review, when you're solving a proportion problem, your first step is going to be to write your word ratio. Your second step is going to be to draw your 4 boxes and fill them in. After that's set up, that's kind of the hard part. Then you do cross multiplication. So you're going to multiply whatever's diagonal, circle those, and multiply those two numbers. And then divide by that number you haven't used yet. And then whatever you get when you divide is your final answer. Okay, that's solving proportions. I'll see you soon.